Let's talk about the basic shape of the surfboard. If you look at the surfboard from the top, this of course is the nose, this of course is the tail. And the coordinates that give you the perimeter of the board when you view from the top, this is called the profile of the board or the template. And the stringer runs down the center of the board. So once you know the coordinates on one side, you can generate the coordinates on the other side, of course, by symmetry. If you look at the board from this direction on edge, the coordinates of the bottom curvature of the board, this is called a rocker. And the coordinates for the top deck of the board, relative, of course, to the rocker, determines the thickness at each point along the length of the board, which of course varies with the length. And this variation of thickness with respect to the length of the board is called a foil. We need to specify what the cross-section across the top of the board looks like. It looks something like this. The board is typically pretty flat, and then it comes down near the rails. The center of the board's here. This is where the stringer is. And typically on most boards, this top profile is constant as we move up and down the length of the board from nose to tail. On modern surfboards, the bottom contours are a lot more complex than the top contours. For example, if this is the top of the board contour, the bottom might be flat. It might be a single concave, something like this. It might be a double concave. It might be so-called V, or a bit more rounded. This is called a rolled V. And another common variation that you see is something called a spiral V. This is a double concave, but the stringer is lower along Z compared to the rails. Double concave, but asymmetrical. This is called a spiral V. And these are the most common shapes that you find on the bottom of surfboards. You need to also specify where these shapes occur on the bottom of the board. So let's say this is the rocker on the bottom of the board, and let's say the first 12 inches of the board, maybe it's single concave, and then maybe in this section it's spiral V, and then towards the tail it's double concave. Okay. So this is the transition region here and here, and we have to morph from single concave to spiral V. And typically we do this linearly, so when we're halfway between the edge of the single concave domain and the leading edge of the spiral V, we're going to be, let's say, 50% of the way from single concave to spiral V. And this is going to morph in a linear progression from single concave to spiral V. Likewise from spiral V to double concave. The software takes care of that. So let's talk about how the computer generates the coordinates of the board. This is actually pretty simple. Let's talk about the top contours first. So this is the top of the board looking down on it, and this is the profile. So the computer has to take each of these top contours and scale them along Y so as to fit the template of the board. Okay, that's clear. And for most boards, the top concave is constant from nose to tail. The only difference is it's scaled along Y and along Z to fit the profile of the board. Okay, so the top's easy. Take. So the other thing we have to do, of course, is we have to take the foil of the board, and we have to take each contour at the top and bring its center point so that it lies on the foil. this contour up so it meets the rise of the foil. Okay, likewise here. So that's simple. For the bottom of the board, we do the same thing. We have to scale the bottom contours along Y so that they fit within the template of the board. And we have to put their center points to lie on the rocker profile. Okay. And so now, if we have coordinates along this contour, let's say every ½ inch, and maybe we have a contour here and we have one here that, let's say, 1 inch apart. So here you can see a printout of the computer file for the top of the board. You can see each top contour, and these are spaced in 1 inch increments from nose to tail of the board. And you can see each contour runs from rail to rail across the top. The bottom is the same thing. So the bottom, we can start off with a bunch of bottom contours across the board, and these will be different depending on where we are from nose to tail, as we spoke about. And then we just simply have to scale these to fit the profile of the board. And we have to place their center points, on the rocker profile. And that's pretty much all there is to it. So now you have the X, Y, and Z coordinates for the top and the bottom of the board. With a certain resolution, maybe every ½ inch along the Y, we have a coordinate, and ½ inch apart. And then along this direction, the X direction, we might have a cross section every 1 inch, let's say. I'll talk about more about what kind of resolution we're